just jot this down, and we're just going to talk a little bit about numbers today. Now, just because you guys are smarter than any other 7th grade class I have this year, I'm going to give you this. Numbers are separated into two big groups here. We've got the real numbers, which makes sense, doesn't it? Real numbers. We've got the real numbers. And maybe, just maybe, just maybe you know, if numbers aren't real, if some numbers are real, then other numbers would have to be fake. Now, it's the same word that kind of doesn't necessarily mean close to unreal.
Uncommon.
Fiction.
They're called imaginary numbers. Is that with an AY or RY? Does anybody know who's the speller?
Airy.
Okay. Now you don't need to, just put this in your notes. You don't need to know. We'll talk more about just glance on imaginary numbers before. We are today just looking at what we call the real numbers here. Okay. And then real numbers are split into two categories. Real numbers are split into two categories. The first of which is what we use more often than any other one, are the rational numbers. Okay. And if we have rational numbers, what do you suppose numbers that aren't rational are? Not unrational, but irrational.
Oh.
Okay. Now, if you know anything about what those words mean, it can help you to remember what these things are. If something's irrational, if your parents said that you're being irrational, what does that mean, Morgan?
You're not being real.
Technically, you would be real, but you're close.
You're not being rational.
Actually,
You're not being realistic.
you're not being realistic, or you are not making sense, Charlie. That's the best way.
That's it.
Now, with that being said, here is where the examples really will help you out with irrational numbers. Irrational numbers are numbers that don't make sense. And what they are, there's really only two things you have to remember that are irrational numbers. Okay? The first one is pi. That number up there on the wall, okay, is an irrational number, because irrational numbers do this. Irrational numbers have to be, write this down, irrational numbers are non-repeating or non-terminating, or actually they're the same thing. They're the same. Non-repeating, non-terminating decimal numbers. Non-repeating, non-terminating decimal numbers. And that still isn't going to make a lot of sense until I tell you exactly what things would that be. Okay? If you look at pi up on the wall there, you'll see that it gives you a bunch of digits and then there's 3 little dots that come after it. Those 3 little dots mean that those digits keep going on forever. That's what those little dots mean. Okay? If you look at the pi up there, you will not see a pattern in that. In other words, there are no sets or digits that repeat in any sort of a pattern. Yes, there's a bunch of 9s in there, but they don't repeat after each other. There's a bunch of 7s or whatever in there, but they don't form any sort of a pattern. Okay? So pi, what's that?
1, 4, 1, 5, 1 6.
Yeah, but that doesn't. In order for it to be a repeating thing, it would have to go 1, 4, 1, 5, 1, 4, 1, 5.
16
Ashley?
If you kept going on and on and on, how do you think there will be?
Nope. People have done it to millions of places, and it's never repeated. It's never come up with anything that's whatever there. That's why it doesn't make sense. That is why it's irrational. Okay. The other thing that you have to remember when it comes to irrational numbers are square roots or roots that don't work out perfectly. Okay? In other words, the square root of 4 is 2 because 2 times 2 is 4. The square root of 16 is 4 because 4 times 4 is 16. But there is no number that times itself gives you 2. Don't say 1 because 1 times 1 is 1. Are we thinking 1? Okay. Any square root that does not work out some of them can be simplified, but these would all be irrational numbers. If you took a calculator, do I have a calculator here? No. Not there. If you take a calculator, it's here somewhere, and I plug in the square root of 2. 2, where is it? Square root. Where's the square root of 2? Okay. It goes to 1.414213562373095, and it stops there only because the calculator only has that many digits that it shows. Okay. This decimal would go on forever, and it would not repeat, and it would not end. And that's the same with all square roots that don't work out. Let me emphasize, don't work out. I can't put the square root of 4 over here because the square root of 4 does work out. I can't put the square root of 81 over here because the square root of 81 works out. Okay, so the only 2 things you have to remember that are irrational are pi and square roots that don't work out. Those are the only 2 you have to remember. Those are all irrational. They don't make sense because they're decimal answers that never stop. Okay? Now, with that being said, let's look at what is rational. Rational are all the numbers that pretty much you are familiar with. Okay? All the numbers that you are familiar with. And they get broken down into little subcategories too. Under the rational numbers, by the way, let's put rational numbers are all numbers that work out. Let me get something small here. Rational numbers are all fractions, decimals, any number really that you know, square roots that work out, Okay, any number that you could give me that wasn't pi or a square root of thing is a rational number. 15 is a rational number. 7.5 is a rational number. 8.6, any of those things. 9.2, that's a rational number. 3 3/8 is a rational number. The square root of 25. Why is that rational? Because the square root of 25 is the same as 5. What else do we have? Any of those things. Those are all rational numbers. Okay, so for the most part, every number you know is going to be rational. There's only a couple that I'm not going to talk about those. Now, under rational numbers, we have another little group that we break it into a smaller group, and they are called the integers. And don't let the names get you all like thinking this is really hard stuff. It's not really. Does anybody know what integers are? By the way, every integer would also be a rational number, would also be a real number. Integers, anybody going once, going twice? Kyle?
Numbers that are decimal.
Nope. Positive and negative whole numbers. Okay, integers are positive and negative whole numbers. They are not decimals, they are not fractions. Okay, so examples of integers would be 7, -8, 24. You can't have a fraction. So with that being said, would 8 over 4 be an integer? Yes, it is. Can you tell me why? Alex?
Because it's an improper fraction, so you must go.
Well, because it's the same thing as 2. You always use the simplified form when you're talking about this. So even though it's a fraction, 8 over 4, it really is the same thing as 2. Okay. If it had a decimal, if it was 3.6, that would not be an integer. Everybody good with that? Perfect. Because then we got to break integers down into smaller numbers. Integers get broken down into whole numbers. We just got 2 more groups to go here. And I'm not doing real well with them. What are whole numbers? Anybody? Sam?
Numbers that are this
Those are integers. Those are integers.
Yeah.
Would you say whole numbers that don't have decimals or fractions?
Yeah.
Yeah. Whole numbers are the same thing as integer except for one small thing. You know what it is? Whole numbers are the same as integers except they are
They are negative.
right. No negatives. No negatives. In other words, it is going to be all whole numbers starting with 0. 0, 1, 2, 3, 4, 5, goes on forever. The difference between integers and whole numbers is integers can be the negative numbers. Whole numbers are all the positive starting with 0. And then last but not least, 7th grade. One more, we have what people call the counting or the natural numbers. Can I make another? Did you leave yourself a little group here?
Oh yeah, I got mine.
The counting or natural numbers. I can't read that, can you?
No.
Counting or natural numbers. Anybody want to speculate what counting or natural numbers are? They are going to be exactly like whole numbers except for one incredibly small issue. Exactly the same as whole numbers except, Alex?
doesn't have 0.
Exactly. And the way to remember that is this. When your parents taught you to count, when you were just 9 months old or a year or 12 or some of you last year, when your parents taught you to count, did they go, okay, 0, 1, 2? No, they always started with 1. Right? You know, 0 really is a hard concept because what does 0 mean? Well, kind of. I mean, when you try to, could you teach a baby what 0 is? Bring me 0 cookies and they'd be like, so, counting numbers are the same as whole numbers, except there is no 0. So it starts with 1, 2, 3, 4, 5, and that. Okay? Now to throw that at you a little differently here, if I gave you this number, let's say the number 7, and I asked you to list for me all the different subsets of the real numbers it belongs to, in other words, all those different types of numbers, you would have to give me a list of probably 4 or 5, right? Because the number 7 is a natural number. It is also a whole number. It is also a integer. And it is also a rational number. Okay? We've got that little tree thing. If it's a member of something, of the lower limb of the branch, it's a member of everything above it. Okay? So you have to list it. If they say which subsets to this, of the numbers does this belong, you know, if it's a natural number, it's always going to be a whole number, it's always going to be an integer, it's always going to be a rational number. If I gave you 3.6 and I asked you what subsets of the real numbers does that belong to? Well, if it's a decimal, where does it belong? Taylor,
I'll ask my question.
look at the decimal. Where did I gave you the example? Which group has the decimals in it? Holly?
Rational.
Yeah, exactly. It is just a rational number. It can't be a whole number because we said whole numbers can't be decimals. And it can't be an integer because integers are just positive, negative whole numbers. It can't be a natural number because when your parents taught you to count, they didn't say, okay, 3.1, 3.2, 3.3. Taylor, your question was what?
When you say natural, is that like?
Natural or
just
counting are the
regular?
same thing. Natural and counting are the same ones.
Okay.
I don't know why they put 2 different names, but that's what it is. Sam?
Would prime numbers be kind of like this? Like
Prime numbers, yeah, prime is a whole different thing. It's not part of the classification of numbers. I mean, it's a type of, I guess it's a type of integer, but we don't really go into that stuff. We will continue this discussion tomorrow.